good break, you got some lunch, and you're ready to dive back into the seminar. This is another topic that a lot of you asked to learn about this year, fire codes and fire prevention. So we're fortunate to have Jim Begley with us today to talk about the tricks of the trade, code analysis tips from a fire protection engineer. Jim has almost 30 years of fire protection experience, the majority of which has occurred right here in Nevada for most of the past 2 decades. Based out of Las Vegas, Jim has been involved in numerous projects across the state, working on high-rise projects in Sparks and Reno, mining and industrial projects in Central Nevada, and countless hospitality and mixed-use projects throughout Southern Nevada, to name a few. After being relocated to Las Vegas in 2002 with Shermer Engineering, Jim founded the Fire Protection Group for JBA Consulting Engineers before establishing TERP Consulting in 2010. Since then, TERP has grown into the largest fire protection code consulting firm in the state, with almost 30 staff overall between 5 offices countrywide. As a result of performing work across the country, Jim is registered in way more states than any one person should be. A proud fire protection engineering graduate from the University of Maryland College Park, hence the company name TERP. He's very much looking forward to the start of college basketball season next week, as am I. Hey, Jim, it's all yours.
Thank you so much, Stacy. I appreciate it. And it's so good to be here with y'all. It's obviously a little different being on a Zoom versus being in front of everybody, but I kind of suspect that we wouldn't have 500 plus people if we were doing this in person. So this is great. I had the opportunity some years ago to go ahead and present to y'all, and I know there's a number of people out there in the audience that I've worked with over the past 2 decades, and quite a number of you maybe I haven't, but it's good that we can all get back together in some way, shape, or form. And so hopefully people y'all will get something from this, and please, as we go through, I've got one of my coworkers, Jason, on. He's going to be kind of looking through questions and trying to go ahead and we've got a number of different points at which we'll take questions, and I'll try fielding them as we go through. And so just a start. Stacy kind of gave you my intro already. So just to kind of reiterate, 30 years, almost 30 years in the business, 20 years here in Nevada, and I've done work, not only throughout the state but across the country. And I've had the great pleasure of growing our firm from starting off here at the house to 5 offices across the country. We have 13 degreed and licensed engineers across the country. As I said, licensed 43 states, and with a preponderance of our staff here on the West Coast, in our most recent office, which we opened, which was in Baltimore, right at the beginning of COVID, as a matter of fact. Just a little bit about our role. We're generally fire protection engineers, code consultants. We have some accessibility experts on staff, but the key of what we do is we interpret code, and then we serve as a liaison between y'all on the design team and AHJs. And so that's really what we bring to the table. Code isn't always black and white. There's a lot of gray, and that's what we specialize in. And for anybody who's been in business for quite some time, even going back to the old UBC days, you can see how significantly both the building code and fire codes have expanded over the past 20, 30 years. And so totally understand that as architects, you kind of have to go ahead and take care of all the disciplines. And so we as specialists work specifically with the codes and code interpretations, working with fire marshals and building officials. And so that's what we bring to the table. We're unlike, say, mechanical engineers, electrical engineers, where you have to kind of have them on all the projects. we're involved when specialties, when in special situations where things get a little bit more difficult. Maybe it's not exactly, your project doesn't exactly meet the letter of the code. And just a little bit about this presentation. Most everything we're looking at is going to be base code. We can certainly talk about state of Nevada provisions. Obviously, we've got some special provisions such as modified sprinkler thresholds, and probably more important than anything else, the 55-foot high-rise threshold, which of course, even that is now kind of changing depending upon the jurisdictions that you happen to be working in. As we're all probably pretty familiar, 75 foot is the base building threshold for high-rise provisions. And anybody that knows a little bit about the history of these provisions knows that the 55-foot provision came into play because of the MGM fire. And the MGM fire, which not only impacted Southern Nevada codes, but codes throughout the state, and still has a lasting effect on what we see relative to amendments throughout the state. If you have any questions, we're going to focus on Nevada, but please, if you have questions about other jurisdictions, do feel free to chime in as we go through, and we'll do our best to go ahead and see what we can answer. If we were doing this in person, it would be a lot of interaction, and so from that standpoint, please do go ahead and ask questions, and I'm going to take multiple moments throughout the presentation to go ahead and try to answer as many as I possibly can. So first off, what I want to talk about is what our most efficient tool is, what we bring to the table. And it's a tool that obviously y'all as architects also have available to you, but it's what we really specialize in. And that's alternates and modifications, right? The difference being that alternates essentially argue an equivalency to code, an equivalency or a method of design that exceeds the intent of code, where modifications simply recognize that meeting code is impractical. And to give you an idea, and this is probably a number I kind of pulled out of the blue, but essentially we probably write 70 alternates to every modification that we do. Modifications just don't get written very often. They're mostly steeped in structural provisions and mostly in modifications to existing buildings. So we're existing structural. We're going to go through and show you some examples, but you'll see where that comes into play, where existing structural provisions, not something that's not easily modified in the field, impacts what is required by code. Whereas alternates are pretty much most everything else. So let's start with the alternates. Alternates, known by any variety of names depending upon exactly what jurisdiction you might be working with. Our company standard, we'd like to call them requests for alternate methods. But the code indicates, the code verbiage in particular talks about alternate means and methods requests. Other jurisdictions will call them code equivalencies or requests for variance. I'm sure everybody on here has dealt with them in one way, shape, or form over their careers. And those are driven by IBC section 104.11. This is the code, that's the provision in the code that allows the building official to accept alternate means and methods. And here it is. Here's just an excerpt from the code. And as you can see, in particular, it talks about the proposed design complying with the intent of the code, so meeting or exceeding what the code requires. So we'll look at some examples, and hopefully that'll become clear. And the reason why this is so important, these concepts with alternates and modifications are important, is because we don't live in a world of black and white. There are a lot of gray situations that don't specifically meet code. And so this is when the negotiations become important, the interpretation becomes important. And this is why it's important for y'all as architects to have a baseline understanding of the building and fire code provisions. And what I'm talking about here, both alternates and modifications, this is not something that you need not that I'm trying to keep myself out of work, but this is not something you need a code consultant for. As long as you're a licensed design professional, you can go ahead and you can pursue these types of approvals. And I'm sure many of y'all have gone ahead and done that. First example is actually probably the pretty easiest, which deals with future code adoptions, aka a chip shot, right? This is the provisions that are going to be adopted, but aren't yet adopted because, of course, current code, the 2021, for instance, which is the latest edition of the IBC and IFC, the ICCI codes, that has not yet been adopted by any jurisdiction here in the state, probably not anywhere nationwide at this point, right? It takes a couple of years for jurisdictions to go ahead and adopt codes. And so we like to look forward to see what exactly is involved in, and what exactly is allowed under the future code provisions, and see if it's practical to go ahead and apply them to our current projects. A couple of examples: egress width factors. Anybody who's been in the business for now last 10, 15 years may very well recall when egress width factors under the 2009 edition, the reduced egress width factors allowed for sprinkler buildings just went away. And so that left a lot of projects in lurch and a lot of properties. Think about it. You've got a property that was designed to a 0.15, 0.2 exit width factor, and all of a sudden now the only thing you're allowed to use is 0.2, 0.3. How do you make modifications? It becomes very difficult. It was recognized pretty quickly, and the mea culpa came back in the 2012, which is maintained through current days with a little bit of a revision. It came back. It used to be that those modified exit width factors were just with sprinklers. Now, under current code, sprinklers and voice evac. And so elevated it just a bit, but addressed a good portion of the projects that really had issues with them. Because generally, those modified exit width factors aren't going to come into play until you have larger occupant loads. And so if you have a larger occupant load, then you're obviously, the code's going to drive you to fire alarm system and ultimately voice evac. And so it made sense. And it basically rectified a wrong that was implemented in the 2009. Elevator hoistway vents, eliminated in the 2015. We knew it was coming from an environmental standpoint. And frankly, from a performance standpoint, there were concerns that elevator hoistway vents could actually drive smoke into elevators as opposed to actually purging and eliminating it. So they were eliminated under the 2015 edition. Number of projects that were designed under the 2012, knowing the 2015 was eliminating elevator hoistway vents, took advantage of this. And a more recent example now is sprinkler requirements, a very specialized kind of example, sprinkler requirements for Group 2 hangars under NFPA 409. Previously, Group 2 hangars, which are smaller size hangars, required foam systems. NFPA the current edition 409, which will be adopted next year, actually eliminates that provision and allows for closed head straight water systems for Group 2 hangars where only minor maintenance is occurring, so no major maintenance. Like I said, very specialized example, but once again, this is the kind of thing that you want to be looking for as designers. You want to be aware of what is coming up in the code to see whether or not any of those provisions are actually pertinent to your current projects. Straight equivalencies, right? This is a little bit of a different, this is the approach here in terms of an alternate is really trying to take advantage. You can always provide extra, but we all know that extra, it generally equates to cost, right? If you put in additional sprinklers, if you increase sprinkler densities, if you put in additional methods of protection or increase fire resistance ratings, all of that costs. The key when it comes to alternates is trying to take advantage of existing conditions that benefit that promote your argument. So for instance, high ceilings. We love high ceilings. You all as architects love high ceilings. And a good thing about high ceilings is that high ceilings serve as smoke reservoirs, which generally allows you to increase your tenability and subsequently can be used to, say, increase travel distances. number of properties that we've worked with over the years, high ceilings, take that into account because the base code doesn't discern between ceiling height when it comes to travel distances. Another instance is sprinklers. And I say here sprinklers for almost everything. And the reason for that is because sprinklers can help with almost all fire life safety concerns. And they are so effective that their reliability isn't questioned. And what we've got in terms of a first example is one of those is a alternate that deals with future code adoption. This was an alternate that we had written for a project, goes back a little bit of ways, but this was under the building was designed under the 2009. They wanted to take advantage of the previous 2006 or future 2000, that technically at the time was the previous 2006 edition reduced occupant load factors. And it's pretty straightforward. I also want to show you this. You're going to see a number of these in terms of different alternates that we have implemented and gotten approved over the years. I want to take the time here right now just to kind of walk you through the format, because not that there's anything particular to this format, but this is kind of a tried and true method. We've been using this for the life of the company. I used it in previous lives, and it's the way the argument is laid out. And this is something that's really important when it comes to negotiating with AHJs. And so our alternates start with just the subject. What are we trying to do? What are we trying to achieve? Then to a code, then moving onward to the code section, and what does the code require? So this code section is intended to be the code section that you are taking the alternate, that you're writing the alternate against. And that's important because I've encountered instances where a code official will say, I want you to write an alternate, even though this is allowed by code. It's not how it works, right? You're not writing an alternate to a code provision that's already that you can implement. You're writing an alternate to a code provision that you cannot meet. And so you're trying to represent the equivalency. So that code section, and then the subsequent requirement. The intent just goes into a little bit further discussion about what is that requirement intended to do, right? So just a little bit more, I like to look at it as the code requirement is essentially the text of the code, whereas the code intent is, in layman's terms, here's what that code section is trying to achieve. And then you've got the request itself. And in this instance, wanted to use the provisions that had previously been allowed under the 2006 and were to be allowed under the 2012. Then just a discussion, and the discussion just essentially goes into, here's why we think this is an equivalency. Because this is such a simple one, this doesn't lay out in a manner that you'll see in some of the other alternates, where the discussion, I generally like to bring bullet points. So the discussion will entail, we can do this because of A, B, and C. And then in the conclusion, once again, you reiterate, this is why this is acceptable, A, B, and C. And so it kind of, you bring it to the table in terms of, here's what we're trying to do, here's why we should be able to do it. And once again, let me remind you, this is why we want to do it. Pretty straightforward. This is a pretty straightforward type of alternate. I see we have we'll move on. No questions in particular about this. So let's take a look. Okay, let's talk a little bit more about sprinklers. Sprinklers are involved in a large number of the alternates that we work with, particularly because there are code provisions that are disconnected from the need for sprinklers. An example of this would be fire resistance ratings. So fire resistance ratings are tested so fire resistance of assemblies is tested in accordance with ASTM E119. E119 is the furnace test, and it's commonly referred to as the time temperature curve. That's what any assembly is subjected to. And it's a very big fire, and it is not sprinkler controlled. So anytime you have an assembly, you're looking at doors, you're looking at opening protectives, you're looking at an assembly itself, you're looking at a through penetration system, they're all tested to the same time temperature curve. And it is a difficult curve, intentionally a difficult curve to meet in terms of maintaining temperatures on the other side away from the fire. However, to our benefit, those curves don't account for sprinklers. So when you're looking at instances where you may not be able to achieve the fire resistance rating, or it appears you may not be able to achieve the fire resistance rating, then you can look to sprinklers. As I had indicated previously, they're incredibly reliable, which is one of the reasons why AHJs are more than willing to go ahead and allow for sprinklers to provide additional protection when it comes to alternate approaches. The technology, pretty amazing in that the technology itself in general hasn't changed much since its invention in the late 1800s. And for those of y'all that may not be familiar, a wet pipe sprinkler system, the typical ones that you're going to see in buildings, is simply piping under pressure. It's really kind of no different than your plumbing systems. And so what happens is then a sprinkler, when subjected to heat, will go ahead and, depending upon the type of sprinkler it is, will fuse. Older sprinklers had actually fusible metal links, whereas most newer sprinklers have frangible glass bulbs. And that's how sprinklers operate in reaction to fire. But the concepts, the physics behind sprinkler systems are really straightforward from the standpoint that it's simply piping under pressure. So when that sprinkler opens up, out comes the water. It's nothing like you see in TVs or movies, by the way, just in case anybody is wondering. Not all the sprinklers go off at one time. So in case you've never seen sprinklers go off in person, that is not what happens. But the base, so this base code accounts for, there is some precedent relative to the effectiveness of sprinklers when we look at smoke control provisions. Smoke control designs allow for lower temperature rated equipment when you're in a sprinklered building. So the code, there is justification relative to achieving these lower temperatures and maintaining a more controlled fire when sprinklers are present. So how do you go ahead and incorporate sprinklers into your design if you're needing to? Well, one way is to go ahead and just put more water in, right? And that's, you can increase the hazard classification. So say, for instance, you have an office building that's light hazard and you have maybe you have limited fire department access. And so therefore you want to go ahead and to minimize the potential for an uncontrolled fire, or a fire that may require fire department intervention. By increasing your sprinkler density, increasing your classification, not only are you increasing the amount of water you're putting on a fire, but you're also decreasing the spacing of sprinklers, thereby increasing the possibility that you're going to control a fire. Regular sprinkler systems aren't intended to suppress fires, they're intended to control fires. However, I will tell you that regular sprinkler systems will generally put out most regular types of fires. And then a little trick, this is a particular trick of the trade, is when it comes to sprinkler design, sprinklers are designed with demand calculations, but supply calculations can actually provide you with substantially more water on a fire. And we're going to go ahead and show you a couple of examples of that in a moment. Also, do remember where if local amendments require sprinklers that aren't otherwise required by the base code, that can also be used as justification. For instance, let's say you're in a jurisdiction that requires patio sprinklers, and which would not otherwise be required under the base code. That is something that can be used if you happen to have, say, an exposure issue. So here we have a situation. Sometimes alternates are driven by design aspects. So for instance, a designer wants to go ahead and do something that's not exactly within the bounds of code. And so that's understood from the beginning. Other times it happens because issues arise in the field. For instance, we had a situation where the contractor wasn't able to go ahead, did not install the proper ceiling system in a type 5A building, which of course is required, which is combustible 1 hour construction. In this particular instance, type X JIP was inadvertently substituted for type C. And if you're unfamiliar with the differences between type X and type C, type X is what you're going to find in most construction. Type C actually is infused with more glass fibers and so it has a greater structural stability. So you'll see type C JIP board in horizontal installations. So ceiling lids, for instance, which was exactly what happened here. So since it was discovered well into construction, we had to look at alternate means of providing the equivalent fire resistance rating. And so for this, we turned to sprinklers primarily. We took a look at the assembly and the discussion, once again, and as you can see, same kind of layout, request, discussion. So there was some discussion as to whether or not we could get 1 hour from the type X versus the type C. And the conclusion was that it was very likely not the case, because generally, if the manufacturer had been able to achieve the 1 hour rating with type X, chances are that's how they would have got it listed, because it's cheaper. And that means if it's cheaper, the assembly is going to be utilized more often. So the baseline was that while we were going to get some level of fire resistance rating, we weren't certain that we were going to get the 1 hour. So what we did here was we took a look at the sprinkler system, and you'll see it says that we took a look at the base design, which would have required a light hazard system. This was a hotel, and would have required essentially a light hazard density, which is a 0.1 over the remote area. This particular building had a fire pump, and so we did, as I said, as I alluded to previously, we did what's called supply calculations versus demand calculations. And you'll see the summary of that there at the top of the RFAM. And what that shows is that we took a look, those areas are the remote areas in the building. Each of them has a different discharge area because you're looking at small compartments. And then we looked at the volume, and you could see those densities. And remember, our requirement was 0.1. C1 had a density of 0.56 GPM per square foot. So almost 5.5 times what's required. Whereas the lowest was almost twice, C4, a density of 0.18. This is because there are safety factors built into designs. So what we were demonstrating was that, hey, not only can we meet the minimum design density, but because of our configuration, we actually have much more water, right? The sprinkler system doesn't know how much water it's supposed to put out. It's simply a mechanical system with water under pressure and pipes. And so by demonstrating this, we were able to prove to the AHJ that we've got so much more water that in practical terms, even though sprinklers aren't accounted for in the fire resistance rating, this assembly will last well over the 1 hour. And as I said, this was supplemented by the fact that we had a fire pump, which certainly drives pressures higher than you would expect from a normal domestic system. This is just, I want to show this to you. I don't know how often y'all may look at sprinkler designs and hydraulic calculations, but what we've got right here, this is basically your safety factor. This is your pressure cushion. And when you do a supply calculation, you're essentially driving the calculation to no pressure cushion whatsoever. So this is the maximum that would be theoretically available from the system given your design pressures. And this can be a little difficult for a sprinkler contractor to kind of get his arms around. Sometimes they need a little bit of prodding to get there, but I can assure you they can do it. They can do it relatively easy. If we were looking at a regular supply curve, you'd see the system demand would be sitting somewhere below the horizontal line, which represents the water supply. And that's where you want to be under a normal design. It's where you're required to be particularly when you're pulling in, if you have required safety factors from a jurisdiction. But in this instance, we wanted to represent how much water we could get out of the system. And once again, we had looked at the summary. This happens to be one of the areas, and just from simple calculations, you can see that this happens to be the one that's 129 square feet. Minimum flow required 12.96, and actual 16 to 21 GPM per head. So you get a lot more water. Even better is that these remote areas are typically at the top of the building. So they by their very definition are remote areas. So therefore, you're going to get even more water generally throughout other parts of the building, particularly on lower floors. So I see we have a couple of questions. Thomas, yeah, I actually started my career in DOE, so I've done fire hazards analyses most of my career. David, so does any of the liability transfer to TERP with an RFAM or an alternate? Well, I would say that no more than any other design professional. I mean, obviously, we are design professionals. We're licensed, registered fire protection engineers. And so we do take on a certain amount of liability. I don't think that we take on, we certainly don't take on all the liability, but of course, yeah, there is, as a design professional, we're certifying that this approach would be appropriate. And right, we don't offer up alternates that we wouldn't otherwise be supportive of. So, so I guess I hope that kind of answers your question from the standpoint that yes, as a design professional, we do take on some of the liability. And then, and Tina, thank you so much for chiming in, particularly because I understand you were one of the people that was instrumental in getting me here today. So, thanks a lot. I see that. So you had a question. What advice can you give? And is it worth having a dialogue with LVVWD relative to sprinklers? Yeah, so I'm a big advocate of sprinklers. As a fire protection, you'd be hard pressed to find very many fire protection engineers that aren't advocates of sprinklers. There are substantial costs when it comes to tie-ins with existing buildings, and in particular, as you had made mention, tie-ins from a utility standpoint can be difficult. There's code issues with it. In terms of having, say, backflow prevention, which of course drives up costs. Water meters drive up costs. Frankly, just an interconnection into an existing main. So my suggestion is that you get out front with developers, with owners, and try to convey to them the benefits, because not only are there the code benefits, but ultimately there are the continuity benefits. If, say, for instance, you've got somebody moving into a building where they're gonna run their business. Well, if your building is sprinklered, then the chances of you having downtime as a result of a fire are significantly decreased. You may be moving into, you talk about older buildings, right? You may have a building that's that even though if it's not historic, it is, you know, it is unique, and you want to go ahead and maintain that. And so retrofitting in those kinds of instances is important because you want to be able to maintain the building. It can be difficult when you're putting a dollar value to it, but I think that if you convey all the benefits of sprinklers, there's a lot of design aspects that you can incorporate into your buildings that you wouldn't otherwise be able to incorporate if you didn't have sprinklers. And so that may very well be the driver when it's all said and done, depending upon the client. And Michael, I see you asked the question about expectancies for approval from AHJs. Well, I have, as a little bit of a spoiler alert, in terms of the discussions with AHJs, I have some bullet points to that later on, but I liken RFAMs to asking somebody to marry you. You know the answer to the question before you go ahead and ask it. So a lot of this stuff, you get a lot of this up front. You kind of gauge in terms whether or not the AHJ is going to be receptive to an approach. Sometimes you don't have that opportunity, right? If a condition arises in the field, then you're kind of stuck with it, and you have to do your best to go ahead and provide an equivalency. But if you're looking at a design aspect in one of your projects, you want to get that up front to the AHJ. And that, to kind of piggyback on that, because Seth asks a question that I think aligns with your question. So it's going to depend. So Seth asks the question whether or not there's a benefit of submitting an alternate in advance of plan check or waiting until the complete documents are ready. And it's going to depend a lot on the jurisdiction. Most jurisdictions will not accept a official submittal of an alternate prior to the actual plan submittal. However, you can do a lot of legwork beforehand. You can determine whether or not a jurisdiction is going to go ahead and accept an alternate or design approach before you even go ahead and submit. That way, then it's just a formality. And part of what we do is essentially trying to gauge what jurisdictions will be open to, right? Because of the fact that you can, if you bring them an idea, sometimes they'll just say, "Oh, absolutely, this is not an issue." And let me take a step back. It depends upon the jurisdiction. I will tell you that I've encountered jurisdictions that literally say, "We will not give you a single opinion or ounce of input until you formally submit." It's unfortunate, but those jurisdictions are out there, whether it be because of staffing or because of just that's their approach towards design. Whereas other jurisdictions are inclusive. They want to be involved on the front end. And so therefore, putting these concepts in front of them long before you get into design and ultimately submittal is very, very important. So I am a big advocate of getting the concepts in front of the HJs sooner than later, getting as much feedback from them as possible. If that means submitting a draft, then that's great. If you can get feedback from them on a draft, I think that's really important. It's going to depend upon the jurisdiction. So I see that we've got some other questions, but I'm gonna move on, and we'll field them here in a little bit. So what we've got next alternate is somewhat similar to the one that we looked at previously. Once again, it was a field condition in a Type 5A building. 1 hour rated rating was required. And in this particular instance, the contractor misapplied the detail. And so they essentially didn't build what was on the paper. What we had here was an assembly that theoretically could have been a 1 hour rating, but didn't have a listing associated with it. And what we've got here, as you see that I've got summarized, is this is one of the sections of code that you really want to be aware of, and it's not one that's used very often, but it's in the back pages of Chapter 7, which Chapter 7 deals with fire resistance ratings, and there is a summary. There's a series of tables in the end of Chapter 7 that outline calculated fire resistance ratings, and this can be very, very helpful if you happen to fall into one of the categories. They're limited, but it can be very helpful if you do. So in this instance, we took a look at tables 722, 621, and 622. And each of these components on those tables is given an equivalent fire resistance rating, which is how we knew at that point that we were going to be very close to that 1 hour rating. Because additively, each one of these components in and of themselves adds up to 60 minutes, even without accounting for plywood, which is combustible, still provides a level of fire resistance. So because we need to provide a little bit more justification, this happens to be just a demonstration of the as-built condition, which was not the listed assembly. We once again turned to looking at supply side calculations. What you'll see here, if you recall, we had numbers that went up to 0.55, 0.58, I think in the last example. Here you're looking at a range between 0.21, or even a 0.16 at its lowest, up to 0.3. Not nearly as robust. Big reason for that, lack of a fire pump. This particular building did not have a fire pump. And the fire pump, as it happens on that previous example, wasn't necessarily required outside of the fact that it wasn't required for the building by the code itself, outside of the fact that there were just lower pressures in the vicinity. In this area, happened to be that the municipal supply was more than sufficient to go ahead and supply to the sprinklers. So what we're seeing here is that just slightly lower numbers. Still looking at least 50%, 50 to 100% more water than you would expect under base design. And that, in combination with the fact that the assembly itself was close to 1 hour, was enough to go ahead and get this approved. Rick has a question about the need to file appeal with the building official and how to do it tactfully without ticking off the plans exam. That is a very good question. So it's funny. So I'm an engineer. I am the least mechanically inclined engineer you will ever meet in your life. So I think I ended up in the right discipline, because what we do, because so much of what we do is code consulting and negotiation. I'm almost much more akin to a lawyer than I am an engineer. Not that I'm not proud of having my engineering background, but the fact of the matter is a lot more of what we do is negotiation. And so in instances like that, right, you just have to have conversations with the plan reviewer, agree to disagree, and then just let them know, hey, I have to move this up the ladder. And in a lot of instances, if you handle it tactfully, it's going to be all right. You might have an instance where a plan reviewer absolutely is adamant that you're wrong. And unfortunately, those things do happen. And it's just a matter of trying to handle it as best as possible. Handle it with kid gloves, right? There are certain instances where people are wrong, and you don't necessarily have to prove them wrong, because that's not going to win you. It may win you the battle, but not the war, right? There's a question about the protocol for submitting an alternate to an AHJ. That's going to depend upon the jurisdiction. And while I'm doing that, I see that Anne, you had wanted to take a look at page 4, the last case study. I believe this is the one you were asking about. But in terms of submitting an alternate to an AHJ, It's going to depend upon their particular process. Sometimes alternates get submitted with the permit package. Sometimes there's a totally separate path. Sometimes fire department's involved. Sometimes they're not involved. Once again, you want to go ahead and convey that you're going to be submitting an alternate as early in the process as you possibly know. Sometimes that's not possible because you just don't know until you get into the field. But in general, you want to go ahead and give them as much of a heads up, HJs, as much of a heads up as possible. So, and in terms, in terms of other protocol, then it's just well, I guess one of the keys is that since alternates can tend to go ahead and hold up plan reviews, it's the other incentive you have to go ahead and submit as early in the process as possible, because you don't want a whole package to be held up on approval of a single alternate. But as I said, certain jurisdictions won't allow you to submit alternates until the package is actually in. So it's kind of a fine line to walk. Hope that answers your questions. And Alexander, we're going to hold on to your question because yours is a little bit more off the beaten path and in depth, but we're not forgetting about you. Okay, so another example of an alternate. This is, I bring this one up because it's kind of an interesting amalgam of base code of record, which for this building goes all the way back to the standard building code, and current code provisions. So have a project where there's a firewall separating high-rise portion of the building from the remaining low-rise. The designers wanted to go ahead and open up the portions of the high-rise to the low-rise. We had gotten involved a little bit later down the line when they realized that, oh, removing this all of a sudden now invokes some provisions in the rest of the building that we can't exactly accommodate. And this in particular was standpipes. So there's nothing in the code that specifically, and this is an interesting one because I even make mention of the fact that I believe, under code intents, while not explicitly stated, is understood that when taken together, if standpipes are required in part of the building, all parts of the building must be provided with standpipes. And so what happened here was existing tower had standpipes, existing low-rise did not have standpipes. Once they opened the two together, all of a sudden there was a need to retrofit standpipes into the rest of the building. Problem being is that old firewalls, and under the SBC, it was actually, it is termed a firewall, whereas under the UBC, as most of us are familiar with, and for those of us that go back to the old UBC days, that's an area sep wall. Well, regardless of whether or not it was an old firewall or an area sep wall, there were structural provisions that are now required of firewalls that did not exist at the time. So now we have, so to exacerbate the situation, anything we tack onto this existing firewall will now no longer meet current codes because of the structural independence provisions. So we took a look and basically did an outline at the request of the AHJ of, hey, what provisions are required, and then what can we do to go ahead and mitigate? And you'll see, not to go ahead and keep on repeating myself, but sprinklers. Once again, we utilize sprinklers as a part of this in terms of increasing sprinkler densities around the openings in the new wall. The argument being that increased sprinkler densities around those openings would reduce the potential for a fire to mitigate, to move from one part of the building from the low rise to the high rise, or vice versa, and essentially provide an extra level of protection around those openings. And then we took a look at the construction type. And the interesting result was that SBC type 1 is actually much more robust than IBC type 1. And the reason for that, well, at least the reason for that, and the reason you'll find that in multiple instances across the codes, is that, okay, let's go back to 20 plus years when the 3 different individual code groups merged to become the ICC. So what you had was you had the UBC here in essentially mostly west of the Mississippi. You had BOCA with the National Building Code, which was in the Midwest and Northeast. And then you had the Standard Building Code, aka the Southern Building Code, in the Southeast and the South. So you had 3 different codes. So when, of course, there was a big push from industry, they wanted to understand why do I have to build, and this came from some of the larger developers. Why do I have to build a Home Depot differently in California? Climate aside and seismic provisions aside, why does the building itself in California have to be built differently than it does in Georgia or New York? And so what you had at essentially the turn of the century was all the code groups came together, established ICC, and each one of them contributed to the 2000 IBC, the original I code. Well, the intent was that because they didn't want to invalidate any of their existing buildings, lowest common denominator provisions were taken from all the building codes. So where you had, for instance, take an example, if you take a look at the table, the SBC type 1 was a higher rating than, and then I believe UBC type 1 fire resistant. And so therefore they had to take the lowest common denominator, and that's how you ended up with type 1A having lower fire resistance ratings than type 1 under the SBC. And this became a pretty important aspect of what we were arguing, because we were able to say, hey, look at this. The existing building is actually more robust than it's required to be under current code. So therefore, there is less hazard to the building in the event of a low-rise fire occurring. And to be honest, I hadn't done a lot old standard building code work. And so that was kind of eye-opening for me. I'm very familiar with the differences between the UBC and the IBC, and that comes into play quite often. But that was a pretty interesting aspect of this alternate. One of the key provisions, key understandings in terms of legacy requirements is that the UBC was a passive base code, whereas both the SBC and the NBC, so essentially the whole rest of the country, those were both active base codes. So there was a lot more weight put onto fire protection, active fire protection, i.e. sprinklers. And so that's why when we transitioned from the UBC over to the IBC, a lot of sprinkler provisions got pulled into play that still remain to this very day. The one caveat is California. Most of the jurisdictions here in Nevada have gone ahead and have gotten in line with the IBC for a number of code cycles. I want to say at least 2, if not 3 code cycles in Southern Nevada. They attempted to maintain UBC provisions, but eventually got away from that. California still maintains a lot of UBC provisions. So for those of us that work across the border, you have to keep that in mind. A big example is smoke control. Active smoke control, no longer in the IBC, still maintained under the CBC. And that's just one of many examples that I could refer to. So the other interesting aspect was that the area and height calculations were also different under the SBC, which is one of the reasons why the building was built as robust as it needed to be. So it was over-designed for the SBC. It was over-designed for current code because the SBC gave less credit to the construction types. And so the combination of those aspects, as you can see here, when we've got it in terms of the conclusion, you outline what our arguments are in the discussion, and then you turn around in the conclusion and say, as a reminder, here's why what we're proposing is compliant. just to check on there if there's any questions. Question about public project requesting a local water agency increase the water stored in their water tank in order to provide sufficient water flow in case of an emergency to an existing school campus. I can't say that that's a common occurrence, but it also doesn't surprise me, not knowing all the particular details of the situation. It might. Thing about water supplies is water supplies can degrade, which is one of the reasons why safety factors are incorporated into sprinkler designs. It's more common for a water supply to degrade than it is to increase. All things being equal, as you know, equipment runs down, as piping becomes corroded, so on and so forth. Valves may dislodge. Anything can happen. So from the standpoint of an increased water supply, you know, anytime a jurisdiction tells you that you need to increase any aspect of the building design without a change in occupancy, I would question it, because legacy provisions generally tend to hold fast. The only instances where you'll commonly run into issues is when you go ahead, either expand a building, or if you go ahead and change an occupancy. Change in occupancy, particularly if you're changing to a higher hazard occupancy, that's always going to invoke current codes. Whereas if you're going from a more hazardous occupancy to a lower hazard occupancy, there's going to be a more wiggle room in terms of negotiating with the AHJs. Carlos has a question about the IEBC. Where fire ratings for type 2 were more strict than current code, should we go with more strict or the current code? So if you're talking about the existing building, I would maintain. But if you're looking at new construction, I think it's 100% feasible to implement current code provisions. That's of course one of those subtleties that you'd have to negotiate with the AHJ. But I think it's reasonable to design it. We have lots of instances where we designed a current code within existing buildings. It happens all the time, right? Buildings are not static; they're dynamic. They're dynamic beings, and so therefore, as renovations occur, it's best to go ahead and incorporate current code. The reason why the IEBC exists is because it is not always practical to go ahead and implement current code. And I will say that IEBC is well-intentioned, but it is not necessarily the easiest code to go ahead and apply. There's a lot of, if you think there's gray areas inside the building code, there's even way more gray areas inside the IEBC. Okay, so next is an example of what's a pretty standard alternate for us. If for those of y'all that do hospitality design, F&B venues, you've probably encountered this provision any number of times, which is textile wall coverings, combustible decorative materials. That's a fancy term for curtains. And as designers, y'all love curtains. That's great, except there are limits as to where you can use curtains. Most occupancies are limited to 10% of a specific wall or ceiling area, which is not a whole lot. So what we did in this instance, and frankly, a lot of instances where this comes up, and this comes up quite often, is sprinklers. So where a designer may want to go ahead and exceed that 10% provision, we look at basically a closely spaced sprinklers along those walls. If you're doing this, if you know the curtains are incorporated in the design early on, this is easy. Retrofitting closely spaced sprinklers, little bit more difficult. But if you're designing a space from scratch, this is a pretty easy, particularly if you're in a building that already has obviously the assumption is that you're in a building that has sprinklers. If you're in a non-sprinkler building, putting in closely spaced sprinklers is going to be extremely difficult. So, and that's really as simple as it gets, is installing, is where that 10% is exceeded, proposing on closely spaced sprinkler heads. And this is a type of alternate that has been readily accepted in numerous jurisdictions in our experience. Just also want to point out that while the crux of the argument, crux of the discussion is based upon the closely spaced sprinklers, there are other aspects of the building that come into play. And this goes back to my point about taking advantage of existing facility provisions. This particular instance, this is a building that has dual pumps, dual secondary water supplies, it has voice evac, none of which have anything to do with the 10% limit on decorative materials. And so those all promote the idea of additional redundancies in the sprinkler system, additional output, and additional capability of people being able to go ahead and move away from the fire in the event something does occur. So, and I see you said that commercial designers do not use curtains. Well, that might be semantics, but I can tell you we encounter them quite frequently. So what we have here, and then this is just essentially, once again, just showing the summary, very similar to what we've seen previously in terms of making the arguments of a alternate, state what you want, and then state it again in the conclusion to kind of to bring it home to the AHJ. And it looks like we have a rather long question about fire code. We'll go ahead and circle back around to that one in a little bit. We see that Jason is answering a question about prosceniums. So moving forward, so this is once again kind of a straightforward type of alternate, but depending on the jurisdictions, some jurisdictions will allow you to go ahead and there are conditions which certain jurisdictions will require an alternate for, whereas they may not be required in other jurisdictions. This is one of those instances, and this is actually an example of a code provision that is now actually allowed. This was an older edition, as you can see. This was under the 2006 IBC. It was for a artificially reduced occupant load factor for some areas that could not meet the exiting provisions, essentially couldn't be provided with two means of egress. And this was high limit gaming. And so this isn't your typical 1 to 11 that you're going to see on a casino floor with mobs of people around a craps table. This is very exclusive uses. And so it was a pretty straightforward argument to make that a reduced occupant load factor would be applicable to allow for the areas to only require a single means of egress. And so this wasn't allowed under the 2006. There was no provision in the code that allowed the building official to straight out reduce occupant load factors. That was subsequently pulled into the code. I want to say in the 2009, might have been to 2012, but there is a provision now under an exception, and that is the exception to 10.04.5 that allows you to go ahead and reduce the occupant load. That same section, I think it might be 100451, actually allows you to go ahead and increase the occupant load factor too. Now, why, you might ask, why would you want to go ahead and increase an occupant load factor, occupant load? Well, money, right? If you have an assembly venue, those assembly venues are going to want to go ahead and have as many people as possible. So therefore, they may ask for additional people. My one word of advice is, if you have clients that want additional people in a building, do take into account that it does not come free of cost. There's the obvious impact, which is exiting capacity, but then there are the less obvious impacts of fixture counts and parking counts. And so just keep that in mind. We get clients all the time that want to increase their occupant loads, but don't take into account that that there is much more than just the life safety aspect when it comes to increasing an occupant load in a building. And once again, kind of the same approach. You've seen this now. I'm not gonna linger on it too much, but make the argument and then go ahead and outline why your argument is effective. So there's a question regarding occupant load factors, and it's funny, Alexander. So we do quite a number of projects with Marriott, and yeah, that is they are steadfast on their 1 to 7. For those of y'all that maybe don't do work with Marriott, Marriott has their own design guide with their own fire life safety provisions, including interpretations. It's called Chapter 14 for fire life safety. And one of their provisions is that large conference rooms are 1 to 7. Now, I will tell you that we have not successfully argued outside the 1 to 7 with Marriott. However, Marriott is more than willing to go ahead and give you some flexibility when it comes to gross square footage. So for instance, let's say you've got a ballroom and the ballroom has alcoves. Those alcoves and even some corners, they'll let you go ahead and not load those at 1 to 7, giving you a little bit more wiggle room. I will tell you that what we've found to be successful in general is a middle ground load of 1 to 10. So 1 to 15, as most everybody I'm sure is aware, 1 to 15 is less concentrated use for assemblies. One person, 15 square feet per person, whereas the 1 to 7 tends to be more of a standing room. It's not queuing, but it's standing room. It's concentrated assembly. So some jurisdictions will tell you that 1 to 7 is what you need to use for large assembly spaces. 1 to 7 isn't realistic in reality, because even if you're set up with a dance floor, you've got tables, even in a concert setting, there's going to be a stage. There's going to be paths to get to the stage. So on. There's going to be paths to get to food and drink, so on and so forth. So what we've found is that in dealing with building owners, the operations personnel that set up and sell the rooms, is that 1 to 10 seems to be a good sweet spot. So you're being conservative. You're being conservative from the standpoint that you're applying more people than 1 to 15, but you're not being so conservative that you're implementing 1 to 7. And while that might not seem to be a big difference, that the difference between 1 to 7 and 1 to 10 is almost 50%. And of course, the difference between 1 to 7 and 1 to 15 is over 100%. And so that can really make a difference. And we found that to be pretty successful, particularly when it comes to HJs that want to go ahead and load pre-function and regular areas simultaneously. That 1 to 10 tends to go ahead and allow for some flexibility relative to the loading of pre-function areas. Carlos, you have a question regarding simulations. So yeah, so you can do modeling to go ahead and reduce exit impacts. So you can do fire modeling and you can do egress modeling, and the technology has progressed immensely over my time in the field, to the point that the current egress models are really they're really very well done. You can assign different types of factors to the individual people. You can have some slower than others. You can have some that may may have bad decision making and go in the wrong direction, so on and so forth. So you can, depending upon the jurisdiction, that is going to be the big driver. I will tell you that we do egress modeling in a number of jurisdictions when clients are looking for it. The one we won't do is we'll get nightclub clients that want to go ahead and, once again, increase occupant loads. Therefore, they want to do egress modeling. We're not comfortable with it, nor are the jurisdictions that we've discussed it with in doing egress modeling in a nightclub setting, because you're talking about people that likely inebriated, could be on any other types of controlled substances, and that decision making isn't something that can really be modeled well. I actually had the opportunity a couple weeks ago. I was at a conference and met with the designer behind the premier egress modeling software. It's called Pathfinder. And I described the situation to him, and he said, I don't even know how I'd begin to model it. I would just basically throw every bad decision and every reduced exiting factor in, just to make these people as mindless as possible. And he's like, even then, I don't even know that would reflect it, because a lot of that egress modeling is based upon actual simulations. Well, you can imagine there haven't been that many simulations of a full-blown nightclub evacuating, caught on film and measured. And so that can be a little difficult, but modeling is expensive. It is not if you've got a simple situation, you can do hand calcs. That will go ahead and reduce the cost, but you don't want to undertake modeling unless there's a significant return on the investment, because a typical model is going to run you anywhere from 20,000 on up, depending upon what it entails. And that doesn't even include jurisdictions will typically require a third party to review any type of modeling of that sort. So that's just another cost on top of it. So now we get to modifications. Okay. So whereas alternates are known by a lot of names, modifications are generally known as RFMs, requests for alternates, not to be confused with RFAMs, of course. And the key with modifications is that's where meeting the code is impractical. I will tell you the majority of these instances have to do with, as I mentioned, have to do with structural provisions. So you're not going to move stairs, you're not going to move columns, and so when this arises, that's when modifications come into play. And I've got a couple of examples here. As I said, we don't do as many modifications as we do alternates, but just to kind of give you an idea of the difference. This is kind of an intro to what we had. So there's and we'll show you the alternate afterwards. But so a property was looking at a restaurant. They wanted to make use of an existing basement underneath it as a back of house prep kitchen. But needless to say, basement wasn't exactly designed to be a prep kitchen. So 8-foot slab, you're already talking about a low ceiling height. You had depressed column bulkheads and existing utilities. Then there were new services that needed to be installed, and health department required a drop ceiling. So all of a sudden, you're going to be well below the minimum 7'6" along the means of egress. We took a look at there we go. Okay, sorry about that. Here we are. So we took a look at the conditions, and for all variety of existing conditions, you're clearly not going to go ahead and raise the ceiling in a basement, clearly not going to move columns. So if anybody tells you that being a fire protection engineer is glorious, I will show you this, where we measured percentages of ceiling heights in a space to determine exactly what percentage of each of the space of the space was at various ceiling heights. And it's fun to look back at this. This is one that I did quite some time ago, and I honestly I kind of remember it as if it was yesterday. So we took a look and basically broke down the area. So here's 35% of the floor area was compliant. Had another 10% roughly that was 7'2", 16% under the 7-foot drop ceiling, because the drop ceiling was only above the food prep areas, and 7-foot regular ceiling, and then there were some 5-foot areas. And in particular, we called out 2 areas where there was a 6'2" electrical conduit. We put in a gate, and then we justified the 5-foot area in the back of house area, in behind the outside of the regularly occupied area by separating it in a mechanical. And ultimately, it got through. That was quite a bit of back and forth, to be honest. But eventually, we were able to get it through. That was one that was not expected, right? The designers didn't go in realizing that they didn't have the clearances until everything got put on paper, and then we realized, wait, we've got an issue here. And luckily, it was one where the jurisdiction was willing to go ahead and work with us to get it through. So before we move on, there was a question regarding exiting. SoFi, I am not intimately familiar with SoFi. The interesting thing about Stadia is that you're allowed to use smoke protected egress widths. And so what may appear to be less exiting than is required is actually allowable, because the concept is that the occupants will not be subjected to the conditions of fire. So smoke banking down, tenability is maintained. And so that equates then to a reduced exit width, which essentially equates to a slower egress time. So I'm not familiar with SoFi, but I'm fairly certain that a project of that high profile was probably looked into. I'm confident that was the case, and that situation was assessed. So if we have no other questions regarding alternates and modifications, now what I want to get into is just want to talk about a couple different topics. I want to talk about egress, because just to kind of give you some rules of thumb relative to egress. So egress is a lot of what we do, needless to say, right? It's a lot of what y'all do. And, just kind of like some simple means to go ahead and determine what requirements are applicable to what portions of the means of egress. So means of egress is divided into 4 parts by code, right? You got your exit access, your exit discharge, and public way. So determining what portions of the means of egress, determining where you are in the means of egress is important relative to the requirements. So the way I do it, and the way I've always taught other people to do it, is that determine where the exit is. And once you determine the exit, then you can determine everything that's exit access, which is everything leading up to it, and everything that is exit discharge afterwards, because public way becomes pretty clear. Public way is easiest to define. So what you'll see is that the exit definition of exit really doesn't give you a whole lot of input, right? It just says the portion of the means of egress between the exit access and the exit discharge. way I like to look at it is, I was taught, it is the point at which travel distance is no longer measured. So think about a high rise. Once you get into the stairwell, you can be 120 stories above ground, and at that point, that travel distance is no longer measured. So if you can determine where that component is, where exit distance is no longer measured, then it's really easy to determine what's exit access, everything leading up to it, and then what's exit discharge, whatever's after it. That can generally be pretty clean, but there are certain instances where it becomes a little complicated. Common example would be an exterior door. That exterior door is the exit, right? So everything up to the exterior door is exit access. Everything outside the exterior door, exit discharge. And basically the one component you are not ever physically in the exit when you're looking at an exterior door on a level of exit discharge. Where it can get a little more complicated is with the concept of horizontal exits, which, because they're so specialized and such a good tool of ours, we're going to talk about separately. But as I had indicated, high-rise stairwell, that's the point at which travel distance is no longer measured. So you're inside the exit once you're inside a high-rise stairwell. Here's an example. See, exit doors at grade, exterior exit stairway, interior exit stairway. Exits can come in many ways, shapes, and forms. Exit passageway is another form of an exit. That can be either as a continuation to an enclosed interior exit stairway, or it can be on its own, where you have exiting at grade and you want to go ahead and address travel distances. So as I'd said, exit access is anything that leads you up to the exit. And as a sidebar, this figure just totally cracks me up, these little stick figures. I don't know, it's just me, but you've got this is a typical configuration of two enclosed exit stairways, each side of the building. Everything on the floor plate is exit access. Everything leading up to it is exit access. The majority of what you're going to deal with is going to be exit access. And then you've got a diagram showing the exit discharge, right? An exit discharge is simply the area between the exit and the public way. And it's important because your provisions, the requirements regulating the criteria for each one of these components differs. And the farther away you get from the building, clearly the less regulation there is, to the point where essentially once you're on the public way, anything goes. In that you're no longer going ahead and measuring exit width. You're not worried about capacity or direction. Once you're on the public way, you're free and clear as far as the building code is concerned. And here you go, just definition of public way. Now, this leads to interesting, for those of us that are in Southern Nevada, it leads to an interesting question, in particular with when it comes to, say, Fremont Street. Fremont Street is covered, but it is still considered public way. That's where you're, all the casinos fronting onto the Fremont Street experience exit to. And so while it doesn't strictly meet the definition of public way, it is truly a public way. Very similar to, there are lots of instances where as the interior and exterior spaces kind of meld, you run into this issue more often. So, and as I said, the reason why it's important, just as a little kind of reminder, is that once you define your exit, then it's very easy to go ahead and determine what applies to exit access and what applies to the exit discharge. And that is just one of those rules of thumb that just makes it a lot easier when you as a designer are looking at means of egress in your projects. But I do want to spend just a little bit of time on horizontal exits. Now, dependent upon the types of buildings you work in, you may or may not be familiar with horizontal exits. Horizontal exits are used quite a bit in institutional uses, healthcare, and they're also used in large assembly spaces. And the reason for this is because in large buildings in general, because if what a horizontal exit is horizontal exit is essentially a part of the building that serves as the exit. And the concept, I've had instances where you introduce this to an AHJ and they get they can be very confused if they haven't actually encountered it before, because it seems counterintuitive. I would even say that it's like black magic. I've had instances where AHJs have questioned whether or not it's actually even allowable, truth be told. They're not free, but they are very, very beneficial when it comes to larger buildings and larger occupant loads. There are provisions, there are certain criteria that you need to meet. You cannot have more than half of your required exits through a horizontal exit. And the key provision is that you've got 2 hour separation going from exterior wall to exterior wall and to roof if you don't have a 2 hour rated floor slab. So what you're essentially doing is you're essentially creating a 2 hour box. And that 2 hour box is the equivalent of what you would find in a rated stairwell. And so you've got a rated, so instead of having a vertical stairwell, you've got a horizontal exit enclosure where people enter into, and at that point then can meander off to any other exit. You have to have refuge area, generally 3 square feet per person. That can be in corridors, that can be back of house areas, it can be anywhere that's generally open and accessible. Can't be behind locked doors. You have multiple tenants, can't be in another tenant space. And then if you have a building that requires standpipes, you have to have standpipe outlets on either side of the horizontal exit. Once again, very similar to what you would find in a stairwell. But it's important that travel distance and exit capacity are no longer measured. So that means what we got is an example here where you have building occupant. So this is a building where we incorporated a horizontal exit. You have exits, and then you've got your horizontal exit. And this horizontal exit in particular, which is the length of the wall, actually is utilized by 5,400 people. So in a representation on paper, those 5,400 people go through that door and disappear. Now, what we do have, can't see it, can't necessarily see it, but there is an area of refuge calculation. And so all the area that happens to have dots, that is used in the refuge area calculation. And so you've got instances where people go through and then on paper, they simply disappear. And you can understand why an HJ, and frankly, even some designers may find that somewhat interesting and maybe even uncomfortable. But it is a great tool, particularly if you happen to be in type 1 construction where you already have 2 hour rated floor slabs. And it's pretty versatile when it comes to exiting significant numbers of people, be it for either travel distance and or capacity purposes. And what we've got here is just that same project, just showing just a representation of our exit capacity tables. And, in terms of sending people through the horizontal exit, rather than having them go directly, having to account for them from the exits of the buildings themselves simultaneously. So now I want to talk a little bit. So a number of the questions that had been brought up previously were asking about the process, right? And part of the process is having a good relationship with your AHJs. You have to try to approach it as a team from a team standpoint. I think we all know there are HJs out there that actually try to be a part of the design team. And that can be a little bit difficult, but that I would argue that that's certainly better than those that don't want any part of it whatsoever and are actually confrontational, which there are those AHJs out there. So one of the things I try to convey to both, my staff and clients is how to go ahead and open up those lines of communication. So first step is get to know your AHJs. So 20 years ago, I came to town. I didn't know anybody. I made a specific effort to reach out to all the HJs in Southern Nevada to begin with, to introduce myself and let them know that I would be hopefully working with them at some point in the future. And some of those relationships I still have 20 plus years later. Attend open houses. If your jurisdiction has an open house, they have town hall meetings, attend them. Introduce yourself to anybody and everybody and anybody you can. Attend local meetings, but you don't want to be, but do this, but don't be disingenuous about it, because a lot of people can understand when introductions are disingenuous. You want to go ahead. You truly need to want to establish relationships with these people. Attend local ICC meetings. That is by far and away the best way to establish a rapport with AHJs, because ICC tends to be very important to AHJs. And so therefore, if you as a design professional are getting involved in ICC, that shows that what's important to them is important to you. And these same traits, what I implement to what I convey to my staff are some of the same successful traits that you can use in your dealings with AHJs. It's important to speak their language, right? I can't tell you how many instances I've had where I'll be in a meeting and an architect will say, that wall is blue. And the HJ says, no, it's red. It's definitely red. Architect insists it's blue. And then I'll say, no, HJ, it actually is blue. And the HJ will turn on a dime and say, oh yeah, that actually is blue. You're right. And that has nothing to do with it. It's because I speak the language, and it's not so, and you don't have to be a code consultant to be able to develop that kind of rapport, but it just goes to show you that in certain instances, if you build that level of trust, then when you come to the table with something that might be uncertain, they're going to be more willing to go ahead and give you the benefit of the doubt. You should definitely know local amendments as much as possible when you begin discussions with AHJs. It's not good to be surprised by something that, now it used to be in the industry, amendments were hard to find. Sometimes they were only printed, sometimes they were printed in limited numbers. Nowadays, almost everybody's amendments are available online. So there's very little excuse for not knowing local amendments. Now, I will tell you though, even having amendments doesn't necessarily mean that you're going to know how every code provision is implemented, because jurisdictions have their proclivities. I'll give you a perfect example. There are certain jurisdictions that interpret fire department access different than others. And so that can become difficult when you go to the building code, you go to the codes, there are no amendments, but it's just a means of implementation that's never truly been documented. And so you go in with a design that you think is completely compliant, only to find out that, nope, this isn't, this will not fly. And you can be excused if you don't know those, because frankly, sometimes those sneak up, even in our line of business, sometimes those sneak up on us because you can be subject to the whim of the jurisdiction, particularly on the fire side. Fire code has provisions that I used to call the God clause that allow the fire code official to interpret codes in pretty much any manner they wish. Building officials don't generally have that same kind of leeway. The fire officials do, and there are ones that will use it to their advantage. And then be cognizant of other entities that may be in play. This is important because even though something may be all right from a fire life safety standpoint, doesn't mean that health department will agree, doesn't mean that elevator division will agree, It could be any could be a problem with zoning. Just keep that in mind when you're dealing with building and fire officials. And when it comes to working through problems on projects, right? It's the subtle art of negotiation. I've found that it's always best to give HJs an out. Proving yourself right doesn't necessarily win you anything, particularly if they decide that they need to go ahead and, certain personalities decide that they can't be seen as having been wrong. I think there was the question about that's how you handle a plan reviewer that may be wrong and you have to move up the chain. You have to try to give them an out, and a lot of that is dependent upon the situation, right? You want to be forthright. What do I mean by that? I find that in dealing with the jurisdiction, if you convey to them that, hey, here's our situation, and this is really this is what it is. Most jurisdictions are understanding. Jurisdictions understand that developers want to design, but they also have to control costs. And so while cost can generally never be the primary factor in terms of negotiations with a jurisdiction, and it certainly will not be considered over safety, jurisdictions, AHJs are people too, and they understand, and they are not in the business of not promoting construction and advancing their communities. So it's always good to kind of be upfront in terms of the situation. I referred to it previously. Alternates, RFMs, like popping the question. Know the answer before you prepare and submit. You might be certain jurisdictions might force you to submit without having that input, but I will tell you that is very much the exception and not the rule. I think maybe 1 in every 20 to 25 jurisdictions we run into might go ahead and not want to give you input up front. And most jurisdictions will not tell you that they'll accept something until it comes in on paper, which is their right, of course. But if you do a good job of outlining exactly what it is you're trying to do, and there are no surprises, then it shouldn't be a problem. Key when it comes to negotiating with AHJs, respect setting or established precedents. Okay, a lot of jurisdictions do not want to go ahead and set precedents or do not want to vary from established precedents. So it is up to you to differentiate why your condition doesn't set a precedent. It might be, for instance, that you have a certain type of occupant that's different than generally expected. It might be that you have different business hours. It might be that you're in a different type of business altogether. It could be anything, but look for differentiating factors. If a AHJ is concerned about a precedent, look for means that differentiate your condition from what he or she is concerned about. And then, read the room. I think people have asked the question about knowing in advance. Part of this comes with just gut feel. When somebody says yes because they have to say yes versus yes when it actually is yes. And they'll generally make it clear without saying it. You can read hesitancy in a lot of instances when it comes to plan reviewers and AHJs. So don't always take yes as yes, because it isn't always. And then make sure you have the right resources. So everybody knows the base code, but you've got commentaries, right? And official interpretations. If y'all don't have y'all don't have copies of commentaries, you should get them. If you're doing enough work in those types of buildings. So the commentary does a good job of expanding upon what the base code provisions are. And while codes are required to be online because of legal rulings, that's the one reason why you can find all the IBC, IFC, all the I codes online, in addition to all the NFPA codes, is because they're forced to put them online. Legal rulings have determined that if you've got a standard that is required to build a building and required for the general public, then those have to be available free of charge. And so that was a big deal. And these code groups, they make a lot of money off of printing books, and so they've tried to find other ways to go ahead and make that revenue. So for instance, the online access it's available, but it might not be the most efficient way of looking at a code. You've got ICC gives official code interpretations. Those are important when there's something nebulous, and that is as official as the code itself. Commentaries, generally, commentaries don't go through the same level of scrutiny that an official interpretation does. So a commentary, there can be some room for negotiation relative to commentary verbiage. Official interpretations, those are the end of the line relative to any type of nebulous situations. And so official interpretations do generally tend to end up becoming code provisions later on in life. And so if you have an ICC membership or have access to somebody with the ICC membership, you can get access to official code interpretations. I put in Google, but seriously, Google is amazingly effective when it comes to being a resource relative to these various questions that you may have. So if you have an obscure code provision, Google it. I'm not ashamed to say that I do it, and typically a jurisdiction has encountered it. There might even be an official code interpretation, or it might be a local code interpretation. So I think it's if you're not Googling is a skill, and while clearly for those of y'all that showed up early in the session, while I may not be good at Zoom meetings, I'm very good at Googling. And that is a very important part of determining paths forward sometimes when it comes to code interpretations. And then future code provisions. We talked about this earlier. Future additions of the code are really important, even when it comes to current design, because if something's been accepted in the 2021, then chances are you can get it through under the 2018 and previous additions. So that brings us to highlight. I want to highlight some of the provisions that are changing under the 2021. Some of the concepts that will be regulated. And before we get into that, got a couple of questions that I'll field. Seth had a question about a interior exit stair leading directly to a horizontal exit. Yeah, Seth, that's funny that you bring that up, because we've actually encountered that. And while technically you should be able to do that, we've seen that jurisdictions are somewhat hesitant at allowing that. So though in concept, you should be able to exit a stairwell through a horizontal exit at grade. But I will tell you that most jurisdictions we brought the idea up to have been somewhat hesitant to go ahead and allow it, though I think it certainly is a concept that does have legs, and is worth pursuing depending upon the situation. And then Tina, yeah, third-party planning examiners. We encounter them quite often. There could very well be some of them on this presentation right now amongst the 500 and odd change individuals that are watching this. Third-party planning examiners, they can be a bit difficult depending upon the situation. And it is, a lot of instances, it's because, in my opinion, and this is just my opinion, they want to prove their worth to whatever jurisdiction is they're working for. That's not to say that that is a, broad brush stroke of all third-party reviewers, but I will tell you that in instances where we're dealing with third-party reviewers, you can tend to see, in our experience, more comments, and it can be a little bit more difficult to get through. But it's once again just one of those instances where you just have to kind of handle each and every condition with a little bit of grace, kid gloves, and hopefully you have a strong enough relationship with the AHJ and they understand the situation. And Dale, it is not, that radiating pattern is from shutters and is not on purpose. So now here we are to some of the changes under the 2021. And we're going to look at changes under both the IBC and IFC. So you can kind of group these changes, most changes, into a couple different kinds of bins. One of which is what I call representative changing times and technologies. So for instance, you've got ESS systems, right? ESS systems 10 years ago weren't nearly as prevalent as they are now. And codes take a long time to go ahead and incorporate. You've got to remember that the 2021, that changes began to the 2021 in the 2019, 18, 19 range, right? So shortly after the adoption of the 2018 code. So that right there, because I codes are on 3-year cycles, NFPA codes generally 3-year cycles, sometimes even more, 5 years, 7 years, depending upon what they happen to be covering. You're gonna have at least a 3-year lag. The other thing to acknowledge is that codes are reactionary. So therefore, when ESS first came, when they first came into existence, and there was no regulation and there were no codes to go ahead and refer to. And so those standards had to be developed, and those are developed over time. And so there's a lag from when a technology is introduced to when it actually begins to get regulated. And it's in that middle ground where you'll have opportunities for alternates, right? Because if the code doesn't regulate something, then you might have to go ahead and propose alternates to go ahead and get a concept through, up until the time at which those concepts get recognized. So ESS is one. We're seeing a lot more of them. We're doing a lot more work on them. I'm sure y'all are encountering them on your projects, and they are regulated. They were considered high hazard. ESS are now considered under the 2021. This is a good shift. Some of the changes I'm going to talk about are going to make things more difficult. Some of them will make things easier. This is one where, in general, will make things easier when it comes to energy storage systems, because they are now generally considered, they're so commonplace, they're being considered F1s. They're not incidental uses. They're not group H's, which might have been argued in certain instances. And so that's good overall. Another good shift under the 2021 is distilleries and breweries. I mean, here alone in Las Vegas, the beer scene has grown by leaps and bounds. I know in Northern Nevada, same thing. Reno and the surrounding areas is a hotbed of great breweries. And so now, it used to be that distilleries and breweries were Group H. They are no longer, under the 2021, will not be regulated as Group H. However, there are a series of requirements that you have to meet that will implement safety provisions to allow them to not be Group H. That's important to keep in mind, particularly if you happen to be working on these types of projects now. If you're working on a brewery or distillery, go to the 2021. It's available online at ICC, and check out what these provisions are and see if they're helpful to your cause. Another type of venue that practically didn't exist 10 years ago, I don't know, it really seems like the last 3 to 5 years they've really hit the scene, is puzzle rooms, escape rooms. Weren't regulated by the code. Certain jurisdictions regulated them as special amusement areas. That has now been codified. So under the 2021, puzzle rooms, escape rooms are considered special amusement areas. This is important because special amusement areas require sprinklers, and they require voice evac and special exiting provisions. You've got lots of mom and pop owners that want to open escape rooms in your standard strip mall. May not be sprinklered, most likely doesn't have voice evac. That can be difficult. We've had instances where we've had escape rooms built in Buildings without voice evac, we've had to put in individual voice evac panels for the room, for the tenant space itself. So keep that in mind if you're dealing with an owner that wants to do an escape room. The good news is that now there's clear direction. So you're not subject to, you're less subject to the whims of an AHJ than you would have been previously, where there was no provisions. Gender neutral bathrooms, right? I think anybody that traveled to major cities, these have been around for quite some time, but they weren't readily allowed by code. They are now allowed under the 2021. So that's good. It provides direction and recognizes what's the changing times. Another type of construction that has really come to its own the last 3 to 5 years, shipping containers. Chapter 31 now has a whole section on shipping containers, most of which is structural provisions, but at least there's direction as to how shipping containers can be used in construction. Mechanical access enclosed parking garages. This is now a defined term under the IBC. Think Carvana, although it could be any type of enclosed mechanical access garage, right? Now the code outlines provisions under 40664. 2-hour separation is required if you're in a building with other uses. Mechanical smoke removal controlled from a fire control equipment room, which is essentially a small, it's a fire command center light, if you want to think about it that way. Fire department access doors around the perimeter, and emergency shutdown switches also in that same fire control equipment room. Once again, this is good because if you're dealing with this kind of application, now there's clear direction in the code as opposed to it just being nebulous and up to the whims of the AHJ. Occupied roofs. Occupied roofs are everywhere. And they have been for quite some time, but it took a long time for the codes to recognize occupied roofs. To the point that provisions have been pulled into the 2021 to address most, but not all of the issues associated with occupied roofs. So off the bat, so occupied roofs, the provisions have been expanded under 50314 under the 2021. So as a kind of a rundown, so you're allowed occupancy to be consistent with whatever occupancy is on the floor below. The exception being sprinkler buildings where you're allowed to have any occupancy up on that level as long as it's allowed under the base code. The things that the code did make clear this go around, that rooftop areas are not included in the overall area calculations, and the occupied roof does not contribute to building height or number of stories. What the code fell short on, and is still in question and still open to interpretation, is whether or not an occupied roof can establish a high-rise building. I will tell you that the jurisdictions that we've been dealing with, both in northern and southern Nevada, have taken the stance that yes, that establishes a high-rise building. And given in conjunction with our 55-foot threshold, can be somewhat problematic. Do remember that that if you have a rooftop, if you have an occupied roof, you have to maintain essentially everything has to be maintained less than 4 feet above the roof surface. So it's truly just an open occupied roof if you don't want it to be considered a story. And just circle back around to the high-rise provision for a second. The reason for the uncertainty is because of the terminology of highest occupiable level, which determines high-rise provisions, versus floor versus stories, which clearly are exempted from occupied roof provisions. And then just egress provisions are clarified in that occupied roofs are treated in a similar manner as any other floor, so it's not concurrent exiting. And the code is clarified that you do, under most instances, have to have an elevator to the occupied roof above certain occupant thresholds. So another concept that is now kind of been pulled in that we've been seeing more of lately, social stairs. I'll be honest, until I started putting together everything for the presentation, I did not know that this was what these were called, but makes perfect sense. And as you can see, it's essentially a social area, somewhat of a combination of a regular stair and assembly seating. And so now the code provides some guidance as to where handrails need to be, that there need to be breaks in the handrails so that people can access the seating areas, and what those widths are for when you have to have more than one handrail. So that's pretty helpful. So just another example of social stairs. 3D printing operations. I pull this in, not that I think that everybody's doing 3D printing operation projects, but because honestly, I didn't know that 3D printing operations were so prevalent that they needed their own code section. Here we are. IFC section 320, in case you happen to be getting into it. Then outdoor artificial combustible vegetation. So the 2018 pulled in provisions for indoor artificial combustible vegetation, but the 2021 pulls in provisions for outdoors. And we can pretty much, those of us that are down in Southern Nevada can pretty much lay claim to the fact that we're the reason why this is in the code. That picture you're looking at, that's the Cosmo. And that is the driver, the 2015, that 2015 event is the driver for why these provisions are in the 2021 code. So if you're like me, you see this stuff everywhere nowadays. It is all over the place. Essentially now that you're regulated if you're within 30 feet of the building, on a rooftop or on the side of the building, and outside of certain size parameters, essentially 6 foot. 6 foot is the parameter. And then you're basically regulated under NFPA 701, which for some of these products, it can actually be somewhat difficult, because for anybody who's dealt with these are plastics, pure and simple. You can generally get compliance with 701 with a spray applied fire resistive product, but it's not always a guarantee. Some other changes, what I like to refer to as clarifications. Atrium smoke control. Atrium is now, encountered this for years because of the definition of atrium, where it talked about 2 or more stories being connected. A lot of people thought that you had to apply atrium provisions where you had it where you interconnected 2 floors. Atria were always design options. The definition has now been clarified to make that more clear, that atria outside of group I's are where 3 or more stories are interconnected. And then there's some leniency on smoke control, where you have atria where only the bottom 2 levels are interconnected. Frontage calculations for anybody that had to go through the mental gyrations on frontage calculations, all of that goes away under the 2021. There's some simple tables at this point. Whether or not it remains to be seen whether or not it makes it more simple. The tables are still a little bit complicated, but it's way better than that, way better than the calculations that we used to have to do. And then clarification regarding combustible stairwells that are now allowed to continue on, where you have stick over type 1, which is very, very common. They're now allowed to continue through into the podium with some increased fire resistance ratings. Recognizes the fact that you want to build, if you've got wooden residence, if you've got wooden combustible construction above, you want to continue that construction as of the stairwell down into the podium itself. Pressurized stairwells, pressurized vestibules. Pressurized vestibules were actually taken out of the code when smoke control provisions got changed, and now are put back in as a design option. I don't know that there are any jurisdictions that wouldn't let you do them previously, but here we are. And a issue that we encounter very frequently is common path of travel for mechanical rooms and penthouses. You got to remember that common path of travel was not a concept under the UBC. So when we got into buildings under the IBC, that became problematic. And in general, designs for mechanical rooms, nobody generally wants to provide multiple exits from a mechanical room. There just really isn't a need. And so now common path of travel, as long as you can exit within the allowable travel distance, you do not need to apply common path of travel to unoccupied mechanical rooms and penthouses. This is an important one and could very well be applicable to jobs that you're currently doing right now under 2018 or 2015. Another good one, door sizes, no longer limited. Used to be that doors were limited to 4 feet. We would do alternates all the time for these types of doors to allow 5, 6 foot doors. Now it's all performance criteria. As long as you can open the door with the same force that you would a regular 3 foot, 4 foot door, you can have it as large as you want. A couple more clarifications. It used to be that that exit passageways had to extend to the floor assembly above. That is no longer the case. The code now acknowledges that you can do a rated lid to go ahead and finish your exit passageway, the top of your exit passageway. Similarly, there's a clarification for ending shafts, right? So IBC section 1511, it's a pretty useful section. We're going to talk, one of my last slides is going to talk about some of these forgotten provisions under the IBC, but chapter 15, this deals with penthouses and essentially roof appurtenances. And so all this recognizes that if you have a shaft that extends above the roof, you don't have to protect it because you generally don't have to protect much of anything that's up on the roof. Some changes come from shifts and hazards. These provisions here under 10.10.2.4 deal with exterior spaces that owners want, that owners, tenants, developers they want exterior spaces, but they want to be able to lock these. They want to be able to lock them due to security concerns, and so therefore these are the provisions that allow you to lock doors from exterior spaces entering back into buildings. And I'm not going to read through all of them. Just know that it's under item 8 under IBC section 10.10.2.4. Most are pretty benign, but one in particular that stands out is weatherproof telephone or two-way communication system. That is something I don't think that most designers are, ready to account for. So just keep that in mind. And we've got a couple more slides. I know we're running close on time, so I want to just kind of get through these and then maybe wrap up with questions. An unfortunate shift is locks in educational occupancies. Of course, this is driven because of the unfortunate shootings that we've had in schools. So now the code recognizes that there are needs for locks from classrooms and outlines provisions. Another interesting provision that in particular anybody who does larger development should keep in mind, because of the combustibility of cars nowadays, open parking garages under the 2021 that exceed a fire area of 48,000 square feet. That's fire area. So that's not floor plate size, that's fire area. And of course, in an open parking garage, it's going to be a single fire area. Generally, you have to be sprinklered, and open parking garages now require automatic instead of manual standpipes. So do keep that in mind. That is actually going to be a pretty big deal, particularly if you're doing large scale developments, or if you do large scale open parking garages. That is a huge cost. And then fire stopping special inspections are now required for Group R fire areas exceeding 250 people. That's going to be most of your hotels, even low-rise hotels, probably going to exceed that number. Was not required under previous editions of the code. There's a couple more. FCCs are now required. Think of this as the Amazon effect. Group F, F1 and S1 buildings over 500,000 square feet. They're minimized fire command centers, but like high rises, they are now required will be required under the 2021. Manual fire alarm systems required in self-storage, public storage buildings in the facility corridors and common areas where 3 stories or more. And here's a big one. Now, it's a big one, but it comes with a caveat. The 2021 will require retrofit sprinkler systems in high-rise buildings. However, the code gives you 1 year to establish a compliance schedule and then 12 years to implement. So 13 years from the date of adoption of the 2021, which of course in some jurisdictions might still be 3 to 5 years out. Still a really big deal though, because a lot of jurisdictions have pushed against retrofit sprinkler systems in high-rise buildings. It's going to be interesting to see how this plays out, because for those of y'all that, anybody who deals with residential, you may be aware of the fact that the IFC pulled in single family sprinkler systems under the 2015, I believe, might even been the 2012, and a lot of jurisdictions locally wrote it out, including a number of them here in the state of Nevada. So this is also something that might get written out. It doesn't affect, funny thing is it probably doesn't affect Vegas as much as it might Reno and frankly, honestly, other jurisdictions, older cities. New York has tons of non-sprinklered buildings, high-rise buildings, as does Denver, as does LA, San Diego, right? Older cities. So I think this is something that isn't going to affect Vegas as much, Southern Nevada, as it would maybe Northern Nevada. Or, Southern Nevada, we have a tendency to go ahead and rip down buildings whenever they get over 10 years old. So just a couple more to go over. Construction barriers are now regulated. They are required to be non-combustible or meet low flame spread criteria. Savvy jurisdictions have already been regulating construction barriers, but now it's a requirement in type 1 non-combustible buildings. Extraction equipment, of course, that's a result of the cannabis industry. What this provision recognizes that there's a listing forthcoming for extraction equipment. It used to be, up to this point, you have to have an engineer certify an extraction equipment because there is no actual listing. That listing is forthcoming from UL. Should be adopted, should be in place once jurisdictions start adopting the 2021. Interesting provision about mass timber. What this is not heavy timber construction, which is now type 4 HT, but these are varying degrees of composites that demonstrate substantial fire resistant properties. And you're not seeing much of it in our areas as of yet, but you do see a lot of it, see a ton of it in the Pacific Northwest. And I suspect that as it catches on, you'll see them elsewhere. And then combustible lockers. I just found that kind of interesting. They're now regulated as interior finishes. So this last chapter, the last item I want to go over is what I refer to as forgotten chapters. Okay, so most of our work deals with chapters 1 through 11, right? 3 through 11 in particular, right? And then, but there are a number of chapters that are important to understand because they'll rear their ugly head, or they could be beneficial depending upon the situation. Chapter 12 deals with interior environment, which sounds relatively benign, but is a coverall for ventilation, lighting, temperature, and deals with unoccupied spaces that kind of fall through the cracks in other sections of the code. Chapter 15, we talked about section 511. That covers anything that rooftop structures that have greater leniency than your building interiors. So penthouses, domes, cupolas, spires. Chapter 26, plastics. This, we refer to chapter 26 constantly. It deals with light transmitting plastics, foam plastics. You can hardly do a job nowadays without plastics, even in non-combustible construction. And so we find that jurisdictions are referring to chapter 26 quite often in their plan reviews, and we're having to implement the provisions in designs. Do recall that chapter 30 now is the basically catch-all for elevators, and whereas there used to be provisions for elevator lobbies in chapter 7 and exit provisions, chapter 10, like everything now for elevators, go to chapter 30. And then special construction, which is one of my favorite chapters, because that's got kind of all the obscure stuff that doesn't really fall into any other place. Pedestrian walkways. If you haven't had to use pedestrian walkways, they're great. They basically allow you to interconnect two buildings without having to credit them as a single building. There's limitations and restrictions, but they're a great concept. Membrane structures are covered under chapter 31. Canopies, awnings are some of the more common applications. But chapter 31, if you're encountering something strange, it's a good chance chapter 31 might have it. And with that said, I think we're running up on the end of time. Stacy, do you need me to wrap?
Yep. If there's any quick questions you want to address, we are kind of at the end of our allotted time.
Yep. No problem.
Okay.
Yeah. We will make slides available. Michael, you'd asked about that. We'll package something together and we'll coordinate through Stacy on that. And Jeremy, you had asked a question a bit earlier about Fremont Street experience leading to future code changes. Yeah, I think I've been lucky enough to have the opportunity to travel internationally quite a bit, and while Fremont Street experience doesn't exist elsewhere in the world, the concept of the melding of interior and exterior spaces is very, very common elsewhere. Hong Kong, you go from streets to outdoor escalators in through the middle of lobbies. And so I think that's where designs are kind of pushing towards, particularly as international influences kind of affect local designs. And I'm sorry, there's two other questions that I probably, Alexander, I can reach out to you on yours. There was an anonymous one about some NFPA 30 provisions. If you'd like to reach out to me, please feel free, and I'd love to be able to help answer that question. And anybody, if you have any other questions, please do feel free to reach out. We'll make sure that slides are available, but I'm pretty readily available. Terp Consulting down here in Vegas. And once again, just finally, thank you for letting me have this time. I really appreciate it. This is I'm looking forward to next year when we can do this in person and we can interact live. So thank you. Anything else you need from me, Stacy?
No, that's it. Thanks a lot, Jim. Lots of good information.
Absolutely. Thank you so much.
Thanks again.